Hello, everyone, and you are welcome to NISA School of Mastery. All right, so we are learning chemistry today, and the topic we are considering electrons. All right, electrons. So of course we'll be reading, and then we'll study together. So let's pay attention even as we go into the class properly. So let's read electrons. Electrons are responsible for the chemical changes in an atom. Therefore, there is a need to study electrons among the other subatomic particles. Yeah, electrons are responsible for the chemical changes you see in an atom. So when you're talking about chemical changes, reactions, and all those things we talk about in chemistry, what is responsible for those things are electrons, not proton, not neutron. All right. So they're what we call chemical changes. They're what we call nuclear changes in an atom. All right. So for your level, most of the things you are doing now are chemical changes. All right. Most of the things you come across in chemistry right now are chemical changes. So at some point you will start diving into, nuclear changes. Are you getting that now? So most of the things you see right now are chemical changes. And I'm telling you right now that electrons are the ones responsible for those things. Interesting, right? That means if we can understand electrons, that means we stand a chance to understand how chemical changes works. Because right now we now know what is responsible for those changes. Are you getting that now? So and that's why there's a need to study electrons separately among the other three subatomic particles. In our other class, we have learned there are three subatomic particles. There's a proton, neutron, and electron. But right now we are isolating electrons because we've seen that it has a greater weight when it comes to chemical changes. I guess now. All right. So let's go. Properties of electrons. They are very light, of course, we found that. They are negatively charged. Yeah. They orbit around the shell in a particular pattern and order. Yeah. They go around the shell. We've learned that before. All right. They have the same number as protons in an atom. Yeah, very important. If you want to know the number of electrons that is in an atom, just go and check the number of protons. So once you know the number of protons, that's the number of electrons. Is that okay? And meanwhile, what is the number of protons? The number of protons is the what? Is the atomic number, right? You remember? The number of protons is the atomic number. So if a particular element or an atom has atomic number 10, so what does that tell you? That means that it has 10 protons, right? How did I know? Because we've already learned that to know atomic number is determined by the what? By the number of protons. So that means if the atomic number is 10, that means the number of protons is 10. That means apparently also the number of electrons will be what? Will be 10. How do I know that? Because the number of electrons and protons are always the same in an atom. Do you get that now? All right, that's good. And lastly, they are orderly and well arranged. Yeah, electrons are orderly and well arranged. Unlike your proton and your nucleus, they are not orderly. So if you look at the atomic structure, the one we learned in our previous class, let me show you quickly. You will notice that the proton, now can you see the proton and the neutron in the middle here? They are more like clumsy. Do you understand that? They are clumsy. Do you get that? It's like they are packed up there. But you look at the electrons, the one in green. If you look at the way they are, you see that they are arranged in a way. Okay? The green ones, you see that they are more like arranged in a way. Yeah. That's what we're talking about. That is what we're talking about. So the electrons are orderly and well arranged, unlike your proton and your neutron. Is that okay now? And that particular property, that fifth one, is very, very important in chemical changes because it is going to lead us to many other things that we are going to learn in this class. So let's read. Unlike the proton and neutron that are simply held together in the central nucleus of the atom, it is not so for the electrons. The electrons are well arranged on the shell and they have a pattern of arrangement. This arrangement contributes greatly to the properties and behavior of an atom. So the fact that electrons arrange themselves has a great effect on the behavior of the atom. And we're going to learn how that works very soon. But one thing you need to know here now is that electrons arrange themselves. They arrange, unlike the proton or the neutron, electrons arrange themselves. And they have a pattern for the arrangement. They have a way they do it. They don't do it anyhow. They don't do it as they wish. They have a pattern in which they all follow. So in this particular class, let's learn that pattern in which they arrange themselves. Electronic configuration. Now let's read. Configuration means pattern of arrangement. That's what configuration means. It means pattern. When you say configure, it means pattern of arrangement. Therefore, electronic configuration means pattern of arrangement of electrons. Good. So when you hear the word electronic configuration, it means the pattern of arrangement of electrons. So we want to learn the pattern in which electrons would arrange themselves. We already learned that they arrange. So, but we want to know how. How do they arrange themselves? It's important we know that. All right. So from the figure 1 above, the one I showed you earlier, okay, the first shell can only take 2 electrons, after which it moves to the second shell. Now, don't forget, electron stays on the shell, right? You remember, electron stays on the shell. So now, when the first shell can only take 2. Let me explain what that means. So let's consider a particular atom. Let's say hydrogen, okay? H. Atomic number what? 1. That's why we write atomic number. Atomic number is written there. Atomic number 1. That means this particular atom, we have 1 proton. Is that correct? Because atomic number is the same as the number of proton, right? So that means it will also have how many electrons? It will have 1 electron. Do you know why? Because the number of protons and the number of electrons are always the same. So hydrogen, atomic number 1, we have 1 electron. So now that 1 electron, where will this stay? No, we are learning electron now, not proton. We want to study electrons. We are studying electrons. We are studying the configuration. How do they arrange themselves? So that particular 1 electron in hydrogen now, so it will look like this. It is a shell. All right. So the electron will be just 1 right there. Okay. So let's take another one. For example, helium. Helium is atomic number 2. That means helium will have two electrons, right? 2 protons and 2 electrons. All right. So the electrons will be on the shell. That's the shell. One over here, and the other over here. Are you getting that now? All right. So let's take the third one. What's the third one? Lithium. All right. So lithium is atomic number what? Atomic number 3, right? All right. So it will have how many electrons? It will have 3 electrons. All right. So how will the 3 electrons arrange themselves? So I will have here 1, 2, then I'll go 1. So what do you notice? Don't mind the diagram, okay? It may not be as beautiful as you will have loved it, but that's not the point. The point is you getting the picture. So what do you notice for lithium? All right, the third electron moved to another shell. So the third electron had to occupy another shell. It was not on the shell, on the first shell. And there's a reason for that. That's because the first shell can only take 2 electrons. Again, the first shell can only take 2. So once there are 3 or more, they have to move to the next shell. So I can't. The first shell cannot occupy 3 electrons. No, the first one it can occupy 3 electrons. So it had to. The third one had to move to another what? To another shell. Is that okay now? That's how they arrange themselves. All right. So what if I have another one? Let's say helium, neon. Rather, let's say neon. Neon is atomic number what? Number 10. Are you getting that now? So it will have how many electrons? It will have 10 electrons. Is that correct? So how will they arrange? It goes thus 1, 2. The first I can only take 2. Are you getting that now? So that means the remaining 8 we have to move to another shell. All right, so 1, 2, 3, 4, 5, 6, 7, 8. So that's the electronic configuration of an helium. Is that okay? Of neon, sorry, of neon. All right. So let's try another one. Let's try sodium. All right. Let's try sodium. Sodium is what? Na. That's what? 11, right? All right. So are we together? So 2 on the first shell, right? The first shell can only take 2. So the next one we have to move to the what? To the second shell. 1, 2, 3, 4, 5, 6, 7, 8. Remaining 1. Out of 11, we have arranged 10. Now it remains 1. So where will the last one stay? Now, what do you notice again? Now, what do you notice? You can see now. You can see here that the second shell can only take 8. That's what is there. So 9 electrons can stay on the second shell. So when it was 8, it had to move to another shell. Are you getting that now? The last one had to go to the third shell because the second shell can only take what? 8. Do you understand? The first shell can take 2. Once it's 2, it has to move to the second shell. The second shell can only take 8. Once it's 8, it has to move to the what? To the third shell. All right, let's do the last one. Let's do the last one just to understand better. Let's do for potassium. Let's do for potassium. Potassium is what? K. That's what? 19. Sorry. 19. So atomic number of potassium is 19. That means potassium we have 19 electrons, 19 protons, 19 electrons. But we want to focus on the electrons, okay? So it goes like this. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Is that correct? So still remaining, we've arranged 10 out of 19. So we still have 9 left. Are you following? 1, 2, 3, 4, 5, 6, 7, 8. So we've arranged 18 now. Remaining 1 left, okay? Sorry. All right. So don't mind the diagram, not as beautiful as you may like it. So 1 there. What do you notice again? The third shell can only take 8 also. So the remaining one has to move to the what? To the fourth shell. That's basically it. So the fourth rather. So the first shell can take 2. The second shell can take what? 8. The third shell can take 8. So once it is complete, it moves to the what? To the next shell.